Welcome to our tutorial on creating a blockchain-based chat application using Java. In this series, we will break down the entire process, from understanding blockchain principles to implementing a simple chat interface. Let's get started. First, let's get an understanding of what blockchain is and why it is a suitable choice for our chat application. Blockchain is a decentralized ledger technology that allows secure and transparent transactions. In a chat application, blockchain can provide verified message delivery and user identity without a central authority. Now, let's outline the main features we aim to build in our chat application. 1. User registration and authentication. 2. Sending messages. 3. Retrieving messages. 4. Ensuring message integrity and verification. Before coding, we need to set up our development environment. Make sure you have Java Development Kit, JDK, installed along with an IDE of your choice, such as IntelliJ IDEA or Eclipse. We'll also need to include some libraries for blockchain functionality. We will use Web3j to interact with Ethereum-based smart contracts. You can add this to your Maven project by adding the following dependency in your pom.xml. Let's create a simple smart contract that will handle the chat messages. Create a new file named chat.sol in your contracts directory. This Solidity contract will allow users to send and receive messages. Now, we'll compile and deploy our smart contract. You can do this using the Truffle framework or any other Ethereum development environment. If you haven't installed Truffle yet, you can do so with the command npm install gtruffle. After installing Truffle, navigate to your project folder and execute the command truffle init to initialize a new Truffle project. Then, move your chat.sol file into the contracts directory of the newly created Truffle project. Next, we will create a migration file to deploy our contract. Create a file called to_deploy_contracts.js in the migrations directory. Here's how the migration file should look. Now that our migration file is ready, we can deploy our smart contract. Make sure you have a local Ethereum node running, or use Ganache CLI to simulate a blockchain. Then, run the following command, truffle migrate. With our smart contract deployed, we can now interface with it using Java. Let's create a Java class that will handle our interactions with the Ethereum blockchain. Create a new file named chatservice.java. Next, we will create methods to send and receive messages in chatservice.java. Let's add a method to send messages to the blockchain. To make these methods work effectively, we need to add the logic for calling our smart contract methods using Web3j. For sending a message, we will send a transaction to the send message function of our contract. Next, we'll implement the getMessages method to retrieve messages from our smart contract. This method will read from the blockchain and return the list of messages sent. The next step is to create a simple user interface for our chat application. We can use JavaFX for this purpose. First, you will need to set up JavaFX in your project. Make sure to include the JavaFX dependencies in your pom.xml as well. Now let's create a basic layout for our chat application using JavaFX. You'll create a class named chatapp.java. Inside this class, we will set up the primary stage and basic UI components such as text fields and buttons. Next, we'll add functionality to our send button to send messages via the chat service. First, we need to create an instance of chat service and set up the button action to call send message. Next, we need to load and display existing messages when our chat application starts. You can do this by retrieving the messages from the blockchain and displaying them in the text area. Now that our chat application is functional, it's crucial to test it. Make sure your local Ethereum node is running and deploy your smart contract. Launch the app, register users, and start chatting. Test sending and receiving messages between multiple instances of your application. In next steps, you can enhance your chat application by adding more features such as user authentication, message encryption, or even multimedia message support. Remember, the possibilities are limitless when developing with blockchain technology. Thank you for joining me in this tutorial on creating a blockchain-based chat application using Java. I hope you found it informative and empowering. If you have any questions or feedback, please leave them in the comments below. Don't forget to like and subscribe for more tutorials on blockchain and Java development. Until next time, happy coding!